Right, so in this video we're going to be looking at something called the binomial expansion, which is a technique that allows us to be able to multiply together kind of identical sets of linear brackets. Now, something you do need to be aware of that this does require knowledge of is your values from Pascal's triangle. So if you haven't yet looked at Pascal's triangle, you'll need to go back and have a look at what comes from there. But if you're happy with that, we shall continue onwards. So, by the end of this set of videos, you'll be able to know the structure and format of how the binomial expansion works, be able to use it to do some multiplying out, use it to calculate individual terms within the expansion, and also do some problem solving in the kind of the style that they expect you to be able to do when it comes to examination. So let's just have a look at the first bullet point in this particular video, which is just looking at the structure and how and why the binomial expansion works. In order to do that, we're going to start by just expanding out these three sets of brackets. Now, you might like to just pause the video for a second and have a go at these yourself. Or let's have a look now at how they're going to work. So the first one, reasonably straightforward. It's just x plus y times by x plus y, bracket times by itself, or squared. Do the multiplying out, you're going to get x squared, xy, yx, and then y squared, and obviously those two middle terms, xy is the same as yx. So those two terms come together to produce x squared plus 2xy plus y squared. For the same bracket cubed, same idea. So what I'm going to do is take my squared bracket and multiply it by one more bracket of x plus y. And again, if you're doing these, you need to kind of make sure that you have a real logic and order to how you're doing things, otherwise you miss terms out. So what I'm going to do is take the x squared term and times by the x, and then times by the y, then do the same for the middle term, and so on. So there's the x squared times by x, and x squared times by y. Do the same for the 2xy, and finally the same for the y squared, and you get 6 terms that look like that. Now obviously again we can do some tidying up, because we've got an x cubed term on its own. Then if you see, we have got an x squared y term here and the small x squared y's here. So a lot of these terms will simplify. So let's just do the tidying up. There's those ones, a bit more tidying up there, and finally the y cubed, and there's our multiplied out expression. And finally, if we do x plus y to the power 4, and again, the easiest way to do that is to multiply together the two squared brackets. So those two expressions are the ones from, that's x plus y squared, which is that one there. Now I'm not going to go through the whole thing here. You can hopefully have done it for yourself, and that's what you end up with. Now, these are starting to look a little bit horrible, lots of powers, x's and numbers going on. But what we're going to do in the next slide is just have a little look at exactly what values we're getting and where they come from. So, there's our squared, there's the cubed one, and there's the power 4. And I've put the coefficients in red because it's the coefficients we're particularly interested in. And if you are familiar with Pascal's triangle, hopefully you're already beginning to spot that these numbers look quite familiar. I'm just going to extend this back up a little bit further as well. So there we've got x plus y to the power 0, and we know anything to the power 0 is just 1. If I do the x plus y to the power 1, that's just that bracket its own, so we get just 1x and 1y. And hopefully now you can clearly see, if we just pick out those numbers, there they go. Those are the numbers from Pascal's triangle. So we know that if we're going to use, or if we're going to do an expansion, the numbers from Pascal's triangle are going to appear in our final result. So the numbers from Pascal's triangle. We'll also notice that if you have a look at the powers of x, we've got x to the power 4, power 3, power 2, power 1, and here we've got x to the power 0, so those powers are decreasing. And if you look at the powers of y, they're clearly increasing. So I've got y to the power 0 here, y to the power 1, y to the power 2, y to the power 3, y to the power 4. So there's real structure to how the x terms are happening, how the y values are happening, and also the coefficients which are coming from Pascal's triangle. If we wanted a general rule, because mathematicians like to be able to express things in a general way, what we've got is that. So x plus y to the m is the same from that horrible looking expression. But if we just unpick that a little bit, you can see in each term what we've got is binomial coefficients, a decreasing power of x, and an increasing power of y. So every single term contains 3 bits, those 3 bits there that I've got bullet pointed. So if you stick to that structure when you're doing these, you're not going to go far wrong. In addition to that, the other things to note are we've got the powers of x and y are adding to n. So here, for example, we've got n minus 2 plus 2, so that's n. Here it is again, n minus r plus r is n. So if I did, for example, a power 6 expansion, my powers of x and y would always be adding to 6. So that's something else just to make sure that you're on the right lines when you're checking that you're getting it right. And the other interesting one to note that's going to be quite useful later on is the power of y. So if I look at the squared term, I've got y squared here. It's the same as that value from your binomial coefficient. So we've got a 2 there, and we've got a 2 there. Over here, y to the power r, and then we've got ncr